Okay, sorry I got kicked off again for that video as well. So let's finish up here. So if f prime changes sign from negative to positive at x is equal to c, if our function goes from decreasing to increasing at some point, then f has a local minimum at that point. Okay, so let's take a look at three examples involving this, where the directions ask us to find the interval or intervals where f is increasing and f is decreasing, and then we're also asked to find the local or relative extrema. And for number one, we have the function f of x equal to 2x cubed minus 3x squared minus 36x plus 14. Okay, so step number one, anytime we're trying to find local extrema, local mins, local maxes, is we have to test the domain of our function, because if there isn't, or if there is a point that we find a critical point at that's not in the domain of our function, then we can't have a local max or a local min at that value. Okay, so the local mins and local maxes that we find have to be at points that are in the domain of our function. And when we look at the polynomial function that we're given in this example, the domain of that polynomial function is all real numbers. So that's good. Wherever we find local maxes or local mins with the sign charts that we establish in just a few moments, our function can have local mins and local maxes at those values. Okay, so once we've tested domain, the next thing we want to do is we want to figure out the critical points of our function. So we want to figure out where the derivative is equal to 0 or where the derivative is undefined. So if we differentiate this function, we are going to get 6x squared minus 6x minus 36. And because the derivative is a polynomial function, the only critical points are going to be where the derivative is equal to 0. There are no points where that derivative is undefined. Okay, so we can then factor a 6 out, which leaves us with x squared minus x minus 6. We want to find where that's equal to 0, and then that quadratic function in parentheses is factorable. It's going to factor to x minus 3 times x plus 2. So our critical points are going to be where those two factors are equal to 0, which are at x is equal to 3 and x is equal to negative 2 respectively. Okay, so we want to figure out where f prime is positive and where f prime is negative, to figure out where the function is increasing and where the function is decreasing. So I'm going to make a sign chart for f prime, and I want to label that this is a sign chart for f prime so I know where I am plugging values into. So when I make the sign chart, I'm going to list the critical points from smallest to largest, and then I'm just going to test intervals. So I think for me, I think the easiest interval for me to test is the middle one, because I can pick 0 to plug in for x in f prime. When I do so, this factor of 6 is always positive, so I don't have to bother testing that factor. So all I need to do is test the values in the two subsequent factors. So when I plug 0 into both of the factors in light blue, first factor is negative, second factor is positive, which tells me the product is going to be negative. And the multiplicity of both of those zeros is 1. It's odd. So the f prime's value is going to change on the two outer intervals. So they're going to be plus and plus respectively. Okay, so once I have that established, we can figure out where the function is increasing and decreasing. So we are going to be increasing where f prime is positive. So that happens on the interval from negative infinity to negative 2, union the interval from 3 to infinity. Our function is decreasing where f prime is negative, and that happens on the interval from negative 2 to 3. And at the endpoints of our intervals, we have to use parentheses at those values because f prime of negative 2 is 0, f prime of 3 is 0. So f prime is neither positive nor negative at those critical points. Okay, so we can't include those on our interval. Okay, and next we want to determine the local extrema. So we have a local max where f prime changes sign from positive to negative. Okay, and f prime changes sign from positive to negative at x is equal to negative 2. So negative 2 is going to be the x coordinate of our local max. And when we plug negative 2 into our original function to get the y coordinate, I'm not going to show the math for that, but the y coordinate is going to wind up being 58, okay, at that value. So the ordered pair negative 2, 58 is going to be the local max. And then we have a local min where f prime changes sign from negative to positive, and that happens at that value in green at x is equal to 3. So 3 is going to be the x coordinate of our local min. We're going to plug 3 into the original function to calculate the y coordinate at that point, and the y coordinate at that point is going to be negative 67. Okay, so again, local maxes, local mins, we have to express those as ordered pairs. Okay, so let's move on to example number 2. So for example number 2, we are given the function f of x equal to x squared minus 4 raised to the 2/3 power. Okay, so what I'm going to do, like, it's good to have the function f of x written with rational exponents whenever we are taking the derivative. But I think when we're trying to determine the domain, maybe it's best to write it in radical form. So if I write this in radical form, this is going to be the cube root of x squared minus 4 quantity squared. Okay, and because we're taking the cube root, like we can take the cube root of negative numbers, of 0, and of positive numbers, the domain of that cube root function is going to be all real numbers. So our function is going to be defined everywhere. We can look at our sign chart for f prime as is. If it changes from positive to negative at a point, we're going to have a local max. If it changes from negative to positive at a point, we are going to have a local min. Okay, so we next want to determine our critical points. So we're going to differentiate f. So f prime of x using power rule and chain rule will be 2/3 times x squared minus 4 raised to the 1/3 power. And then using chain rule, because we have a composite function, we have to multiply that by the derivative of the inner function, which is 2x. So that makes f prime of x equal to, when I write this back in radical form, we're going to be left with 4x. Sorry, this should be to the negative 1/3 power. So we should be left with 4x in the numerator. In the denominator, we're going to have 3 times the cube root of x squared minus 4 quantity squared. Okay, so what we want to do now is we want to determine the critical points for this function. Okay, so critical points are going to be where the derivative is equal to 0. Sorry, that denominator shouldn't be a square. That should be to the first power, because it's to the negative 1/3 power. Okay, so critical points are going to be where the derivative is equal to 0, and that happens where the numerator is 0. So that happens when x is equal to 0. And it's also going to be where our derivative is undefined. So because our derivative is in fraction form, a fraction is undefined when our denominator is 0. And our denominator is going to be 0 at x is equal to negative 2 and x is equal to 2. And I want to change just one more thing with the derivative here, because I think it's going to make it easier to figure out what the signs are when we do our sign chart. So if we do 3 times the cube root of the argument of that cube root function, x squared minus 4, that factors to x plus 2 times x minus 2. And I think that's going to help you when making your sign chart for f prime. Okay, so next we're going to make our sign chart for f prime. When we list the critical points in order from smallest to largest, we have -2, 0, and +2. And then we're going to go ahead and test our intervals. I think probably the easiest one for us to test is the rightmost interval. So if I pick a value bigger than 2, let's say I pick 3. When I plug 3 into the numerator is going to be positive. When I plug 3 in for x into all factors in the denominator, all of those factors in the denominator are positive. So a positive divided by a positive gives us a positive quotient. And then when we look at the multiplicity of the zeros in the numerator and denominator, they are all 1. So that means that the signs have to change on all of the subsequent intervals. Okay, so once we have that, we can then determine where the function is increasing. It's going to be increasing where f prime is greater than 0. So that happens on the interval from -2 to 0, union the interval from 2 to infinity. Our function is going to be decreasing where f prime is less than 0. So that happens on the interval from -infinity to -2, union the interval from 0 to 2. And then for the local extrema, so our function is going to have a local minimum where the derivative changes sign from negative to positive. So that happens at -2, and it also happens at +2. So our function is going to have 2 local mins. So we need to determine the y coordinates at both of those x values. And when we plug those into our original function, we're going to get the y coordinate for both of those points to be 0. And then our function has a local max where the derivative changes sign from positive to negative. The derivative changes sign from positive to negative at x is equal to 0. So we go to our original function. When we plug 0 into the original function, we're going to get like -4 to the 2/3 power, which is essentially the cube root of 16, which we can break that up into the cube root of 8 times the cube root of 2, which winds up becoming 2 times the cube root of 2. Okay, so that is where our function is increasing, decreasing, and where it has local minimums and local maximums. All right, so the third example for this section, the third and final example, will be on video number 3 that I post. All right, hope you guys are all having a great day. Take care.